Hello everyone, I am Riyad Hassan from CSC department. Today we are going to discuss about cell phone charger. At first, meet our team. First there is Tofal Ahmed Nafim, then me, after that Tahmid Alam Arnav, and the last one is Jannatul Firdaus. This is our table of content. Firstly, we will go through introduction, then we will talk about the required components. After that, we are going to talk about how those components works in the circuit. Lastly, we will show you the simulation and the conclusion. Today's cell phone charger comes with a different power supply in the market. In this project, we will be making a circuit to get 5 volts regulated DC supply from 22 volts AC supply. This circuit can also be used as power supply for other devices like breadboard, microcontrollers, ICs, etc. This is our diagram. There is basically 4 steps involved in making a cell phone charger. The first step is stripping down the 222 volts AC supply into small voltage, and the second step is rectification of AC into DC using a full wave bridge rectifier. Since the DC voltage obtained in a second step contains AC ripples, which is removed using filtration process. And the last step is the voltage regulation, in which IC7805 is used to provide the 5-volt regulated DC supply. Now let's see the components required to make the phone charger. At first, we need 9091 a step-down transformer. Then we will use diodes to make full bridge rectifier. After that we need capacitor 1000 microfarad and 0.01 microfarad. Lastly, the voltage regulator IC7805. 909 is a center tap step-down transformer. This transformer converts 222 volts AC supply to 9 volts AC. From the above diagram, we obtain 2 volts VA and VB from 3 wires. The main difference between normal and a center tap transformer is that in a normal transformer we get only one type of voltage, where in a center tap transformer we get 2 voltage. A full wave bridge rectifier is a setup which takes alternating current as input and converts into direct currents. It consists of 4 diodes connected as bridge as shown in the circuit diagram. This process of converting alternating current into direct current is known as rectification. After the rectification, the output is not proper DC. It is a pulsating DC output with a high ripple factor. We cannot feed this output to our cell phone as it's not steady. The pulsating DC output after the rectification has twice the frequency than the AC supply input. By connecting a capacitor in parallel across to the load, decrease the ripple factor and increases the average DC output level. That's all from me. Rest of the presentation will be carried out by my other teammate. Thank you.
Assalamu alaikum, sir. I'm Tahmid Alam from CSC department. My presentation part is working and operation of the mobile phone charging circuit. When the high ripple pulsating DC output is fed across the capacitor, it charges till the wave reaches its peak position. When the wave starts decreasing from its peak position, the capacitor discharges itself and tries to keep the voltage level of the output steady, and the output wave doesn't go to lowest level and hence creates a proper DC supply voltage. Let us calculate the capacitance value, which should be used for filtration. The capacitance can be calculated using this formula C equal to I into T divided by V, where C equal to capacitance to be calculated, I equal to maximum output current, suppose 500 milliampere, T equal to time period, V equal to peak output voltage after filtration. Since the input AC voltage is 50 Hz, therefore output wavefront after rectification will have twice the frequency of the input AC supply. Therefore, frequency f of ripple is 100 Hz. Time period t equal to 1 by f equal to 1 by 100 equal to 10 millisecond. The output to be fed to voltage regulator is 7 volts, 5 volts DC output plus 2 volts more than required, which is to be deducted from its peak output voltage. The 909 transformer gives the 9 volts RMS value, so peak value will be root 2 into RMS voltage in one cycle. We are using two diodes. The voltage drop across the diodes is 0.7 volts, therefore 1.4 volts across two diodes. So finally, peak output voltage V equal to 9 volt into 1.414 volt minus 1.4 volt minus 7 volt equal to 4.33 volts. Therefore, C equal to Q divided by V, where Q equal to I into T. C equal to 0.5 ampere into 0.01 millisecond divided by 4.33 volt equal to 1154 microfarad, which is approximately 1000 microfarad. That's all from me. Next part will be present another team member, Jannatul Fardoos.
Assalamu alaikum. I am Jannatul Firdaus from CC Department. Voltage Regulation IC 7805. IC 7805 is voltage regulator which gives regulated 5 volts DC output. The operating voltage of IC 7805 is 7 volts to 35 volts. Therefore, the minimum input voltage supplied should be at least 7 volts. The output voltage range is 4.8 volts to 5.2 volts and the current rating is 1 amperes. Application areas for 7805 IC 7805 IC is used is a wide range of circuits, the major ones being fixed output regulator, positive voltage regulator in negative voltage configuration, adjustable output resistor. Difference of voltage regulation between input and output voltage. Since the difference between input and output voltage is 2 volts, which is a significant difference. This difference of voltage between input and output is released as heat, and the more is a difference, heat is dissipated. So a proper heat sink must be connected to the voltage regulator to avoid its malfunctioning. Heat generated calculation input voltage minus output voltage into output current. For instance, if the input voltage is 12 volts and output voltage is 5 volts, with output current of 500 meter amperes, then heat generated is 12 volt minus 5 volt into 0.5 meter amperes equal to 3.5 watts. So a heat sink can be attached which can absorb heat of 3.5 watts of power to avoid the IC getting damaged. 7805 voltage regulator IC significance 2 means 78 means positive and 05 means 5 volts. Hence, this IC is used to supply positive 5 volt DC supply. This IC has just 3 pins, one for input, second for ground and third for output. A capacitance of 0.01 microfarad is connected across output of this 7805 voltage. The regulator to eliminates the noise generated due to the transient change in voltage. That's all for me. My next group mate Tufail Ahmed Nafim. Thank you.
Hello everyone, this is Tofal Ahmed Nafim. Now I'm going to show the simulation of cell phone charger. We simulate this circuit using NI Multisim software. For this cell phone charger circuit design, we used 9091, a step down transformer, 4 diodes, 2 capacitor, one is 1000 microfarad and other is 0.01 microfarad. And we also used a voltage regulation IC 7805. After the implement all the component in software, we can see here in multimeter by input 220 to 230 AC current voltage, we are getting 5.003 voltage. So our cell phone charger is working properly. Here is the conclusion. By understanding the above procedures, you can design your own cell phone charger of desired output. Necessary changes will be required in transformer ratings, like you need to choose transformer which can step down to appropriate voltage. The rectification process will be similar, as it will just convert negative half into positive half. The calculation for the capacitor required in the process of filtration must be calculated properly, especially for mobile phone charger. The difference between the input and output voltage of the voltage regulator 7805 must be kept into consideration, and heatsink should be designed accordingly. Thank you everyone. Thanks for watching our presentation.